So hi guys, unfortunately you can't come this time to continue your project on the battery preparation. So we decided to record some videos to explain the next steps of this project. As we talked before, we have three main stages on this project. The first one is the active material preparation. That's what we did during your first visit. In your case, we have this sample with a high entropy oxide. And then we have the slurry or the electrode preparation, which is this step where we are going to prepare the electrode to be used in our sample. And then the third step is the cell preparation. Okay? In this video, I'm going to show how to prepare the electrode for our cell. So during your first visit, we prepared the sample just by ball milling, by mixing the right amount of the oxides together. We made a pellet and then we sintered at high temperatures. After we got the desired phase by doing the XRD, I started to prepare the sample for the electrode. So the first step on the electrode preparation was a second ball milling. So after the sintering, I ball milled again the sample for half an hour, 30 minutes, to get a nano-sized powder. Why? Basically, when you have nano powder, we are increasing the reactivity of our sample, of our material, by increasing the surface area. So the reaction happens first at the surface of the sample, in this case. So we're just trying to increase the reactivity by increasing the surface area, by decreasing the size of our sample to a nano-sized powder. Basically, a slurry, the electrode is made out of this slurry, which is a compound, which is a mixture of 4 elements very important to the sample. First one, active material. Second one, carbon black. Third one, a binder, in this case PVDF. And then a solvent, NMP. In this case, the carbon black is used to increase the electronic conductivity of our material in the cell, and the binder to increase the bond between carbon black and the active material. So the first step here should be calculating the right amount of each one of them. This amount is very important in a cell preparation, and in this case I used 70% of active material, 20% of carbon black, and 10% of PVDF. The amount of NMP varies depending on the viscosity of the slurry that we want. So after calculating this, we have to dissolve the PVDF and into the NMP using just a glass vial like this and some ceramic balls, inert ceramic balls. After dissolving these two together during 10 minutes, I can add the carbon black and the active material in my solution, and all the mixing is done using this small equipment that's a vortex mixer, which I just place my sample there and I start mixing everything. As you can heard, that's the ball hitting the walls of the vial and my solution inside. I did this mixing for 24 hours until I got a nice homogeneous viscous solution. After that, as you can see, that's the consistency of the sample. It's almost black. We have a lot of carbon here, but it's very viscous. I'm going to show later during the casting of the sample. So basically, we are going to use this slurry to cast a film of the sample on top of the current collector. Since we are working with anode, we are going to use copper as the current collector of our sample. and you're going to cast this using this special tool. It's a doctor blade. Basically, it's just a blade that you can choose any specific height for our sample. How am I going to do this? I'm going to spread the slurry. First, actually, I'm going to find the zero position or the surface of the foil by using these screws to decrease the blade all the way down. After I have the zero position, I can turn the screws up and choose a specific height of the film. In this case, we're doing 15 microns. After I have the right height, I can spread the slurry on top of the foil and then slide the doctor blade, spreading everything around. So let me get some of the solution. So now you can see better how it looks like. And then I can put on top of the current collector. And then with the doctor blade, I can just spread the slurry on the current collector, making this nice and uniform film like this. Okay, so right now we have a current collector with a 15 microns approximately film of this slurry. Remember, right now we have active material, carbon, PVDF, and NMP. But we have to dry the NMP. We have to remove the NMP of the solution. We need a solid film. So I have to dry this in an oven during some time. In this case, I did at 50 degrees C during 24 hours. After this drying process, I have our electrode, dry electrode like this. Okay? Right now we have the slurry on top, the dried slurry on top of the current collector. And to increase the adhesion between both, I can do one more step. That's what I did for this project. Basically, I'm using this calendar machine, which has two rolls touching each other, and I'm going to pass this dried foil in between them. Basically, we are going to press this slurry, the dried slurry, against the current collector and increase the contact between both. And then we have the electrode. This one I did already. So after this, I have the electrode that you're going to use. As you noticed, to prepare this, our electrode is not on the right size yet. So basically, I have to cut the electrode on the size that I want to prepare the cell. It's a pretty simple step. Basically, I'm going to use a puncher and a hammer to cut the electrode on the desired size. In this case, I'm going to put the electrode in between two foils to avoid the contact with the table. I'm going to find a nice area and then just hit the sample. As you can see, I did hit strong enough. As you can see, this is our electrode to be used in a cell. We have the current collector here and the electrode on the other side, and you're going to use this guy to prepare our battery. Right now we have here current collector, sample, active material, carbon black, and PVDF. So we have actually to calculate from this only the mass of the active material. With this mass, we can calculate the current density that you're going to use to test the cell, if it's a high rate or slow rate, which means, am I going to charge fast or slow? And also to calculate the specific capacity of the cell, which means how much lithium I can store in this material. So basically, I have to weigh all of them together, and I have to cut a piece of the current collector only with the same size. I'm going to weight this sample, this current collector, subtract from this, and multiply by the amount of active material that I have here, which is 70%. And with this number, the active mass of my electrode, I can calculate the current and the specific capacity. So this video ends here. I have the electrode ready to be done as a cell. And on the next one, we are going to assemble everything inside of the glove box. As we talked before, this cell here, we have several layers stacked together. So basically, it's our electrode. We have a separator. We have the electrolyte or the medium for the lithium to move. And we have a counter electrode, lithium foil. This is a half cell. So we are going to do this inside of the glove box, since lithium metal is very reactive and cannot have contact with the air. Okay, thank you, see you.